1-2, the real numbers. So what this lesson goes over is rational numbers and irrational numbers. We want to keep in mind that our natural numbers are 1, 2, 3, 4, 5, all the way up to infinity. So any positive number from 1 to infinity that does not include a fraction or a decimal. Your whole numbers, represented by W, are 0 to infinity, no fractions or decimals. And then Z is the set of integers, so anything from negative infinity to positive infinity, including 0, that does not have a fraction or a decimal attached to it. Rational numbers can be represented as a fraction. So anything that can be represented as a fraction, whether it be a terminating decimal or a repeating decimal, it is a rational number. Irrational numbers are those that cannot be represented as fractions. So what we are first looking at here are subsets of rational numbers. So we have the first example, 1, for A through D. We're determining whether each statement is true or false. So A, we have 0 is a member of W, which is a whole number. So 0 is a whole number, so this is true. For B, we have N, or a natural number, is a subset of Z, so an integer. N is a natural number, so 1 through infinity, no fractions or decimals. Z is an integer, negative infinity to positive infinity, no fractions or decimals. So this is also true. C says that 0.75 is a member of an integer set. Integers don't have fractions or decimals attached to it. 0.75 is a decimal, so this is false. And then D, we have Z, so an integer is a subset of Q. Q is rational numbers, so Z are integers. Those integers are rational numbers, so this is true. In order for a number to be an integer, it also has to be a rational number. If a number is a whole number, it also has to be a rational number. So graphing on a number line, we're just drawing the number line with the numbers that surround the numbers that we're working with and plotting points. So for example, 2, we're listing the elements of each set and graphing each set on a number line. So A says X is a whole number less than 4. So a whole number less than 4 is anything from 0 to 1, 2, and 3. These are less than 4. So on our number line, we can include -1, 0, 1, 2, 3, and 4. We would just have a point on 0, 1, 2, and 3. B says an integer between 3 and 9. Between 3 and 9 does not include 3 or 9, so this is 4, 5, 6, 7, and 8. So on our number line, we're going to have 3, 4, 5, 6, 7, 8, 9. So this is going to be 9. This will be 3, 4, 5, 6, 7, 8. All right, so between 3 and 9 is 4, 5, 6, 7, 8, and then we're done. For C, we have an integer greater than -3. So that doesn't include -3. That would be -2, -1, 0, 1, 2, all the way to infinity. So on our number line, we would have -3, -2, -1. We can do 0, we can do 1. And then we're going to do these 3 dots after the 1 to represent that it keeps going to infinity. So we're going to have -2, -1, 0, and 1. For our next part, we have irrational numbers. Irrational numbers are those numbers that cannot be represented as a fraction or a decimal. So when we look at these, any radical or square root, cube root, anything that cannot be simplified is an irrational number. With these, for example, A, we have the square root of 5. You cannot simplify the square root of 5, so that is irrational. For B, we have 1/3. That is a fraction, so this is rational. And then for C, we have 5.121212, and it keeps repeating. This is the same thing as 5.12 with our bar notation over that 1, 2. So this one is also rational. For our next section, we're telling whether or not the numbers within this set are rational or irrational. So with this set, we have this negative square root 7, we have negative 1/4, 0, the square root of 5, pi, 4.16, and 12. So our real numbers here are all of these numbers. So all numbers of the set are those real numbers. Our rational numbers are those numbers that can be represented as a fraction or a decimal. So negative 1/4, the 0, the 4.16, and the 12 are our rational numbers. So negative 1/4, 0, 4.16, and 12. Your integers are only the numbers that are not including the fraction or decimal. So that's a 0 and the 12. For example 5, I write this down so that way I can refer to it whenever I am looking at these types of problems. But with this, our natural numbers are represented by n, our whole numbers are w, our integers are z, our rational numbers are q, our irrational numbers are I, and our real numbers are r. So with these, we're telling whether each are true or false. So A says that the square root of 7 is a member of Q. So the square root of 7 is a rational number. This is false. For B, it says Z, which is a integer, is a subset of the whole numbers. Integers are actually it should be the other way around. Whole numbers are also integers. So this one is false. For C, we have your irrational numbers as well as your rational numbers. So the numbers that are the same equal an empty set. So which are the numbers that are the same? None of them. So that just means that an empty set is equal to an empty set, which is true. For D, it says that negative 3 is a member of the natural numbers. Negative 3 is not a natural number. Natural numbers are positive, so this is false. E says that we have the intersection of integers and irrational numbers is equal to an empty set. This is true. For F, we have Q is a subset of R, so rational numbers is a subset of real numbers. This is true because the set of real numbers contains both rational numbers and irrational numbers. G, we have that R, so real numbers is a subset of natural numbers. This is false. Your set of real numbers includes fractions, which are not in the set of natural numbers. For H, it says pi is a member of R, so pi is a real number, and that is true. For our next part in this lesson, it deals with intervals of real numbers. So we have to kind of think about our unions and our intersections with these numbers. So with this example 6, it tells us to write each interval of real numbers in interval notation and graph it. So for example A, it says the set of real numbers greater than or equal to 2. So this equal to 2 means that we're not going to have a parentheses around it, we're going to actually have a bracket around it. So it's going to look like a really boxed parentheses. So we'd have that on that 2, and then it would go to infinity. So this would just be 2 comma infinity with a parentheses on the infinity and then the bracket on 2. So we're going to do the same thing with our number line. On our number line, we're going to find that 2. We're going to write a bracket on it, and then our line will go to infinity. So it would go to the right from there. For B, it says the set of real numbers less than -3. So this doesn't include -3, so you're going to have a parentheses on the -3, and then it would go to negative infinity as well. So it would be parentheses on both -3 and parentheses. So we're going to do a parentheses on the -3 on our number line, and then draw our line to the left with our arrow to represent that it goes to negative infinity. C says the set of real numbers between 1 and 5 inclusive. Inclusive means that it includes 1 and 5. So between 1 and 5 just means that we're going from 1 to 5 on our number line, and we're going to have brackets on those, so that way we represent that it includes 1 and 5. For D, we have the set of real numbers greater than or equal to 2 and less than 4. Greater than or equal to 2 means at 2, and includes 2, so we'll have a bracket on 2, up to 4, but that doesn't include 4 because it's less than 4, so it'll be a parentheses on that 4. So on our number line, we're going to do the same thing. We're going to do a bracket on 2, parentheses on 4, and then draw our line through those. Or sorry, not through those, but connect our line with those. Lastly, we are combining intervals here. So we're writing each union or intersection as a single interval. For A, we have 2, 4, union 3, 6. So this is 2, 4. This is the numbers between 2 and 4 with a union of the numbers between 3 and 6. So this is just going to include all of them. So it's going to be 2, comma 6. We can also think of this as 2, 3, 4 with a union of 3, 4, 5, and 6. So we want all of these numbers here. So it's just going to be 2, comma 6. Oops. For B, we have the numbers between 2 and 4 intersection with 3 and 6. So the numbers between 2 and 4 are going to be 2, 3, 4 with a union of 3, 6. So that's 3, 4, 5, 6. Intersection. So what's the same? We have 3 that's the same, as well as 4 that's the same, and it would include both of those. So we're going to do a bracket on the 3 as well as the 4. For C, we have the numbers between -1 and 2 with a union of 0 to infinity. So this is -1, 0, 1, 2 with a union of 0, 1, 2, 3 all the way to infinity. So what are the numbers that are included in all of this? We have the 0 all the way to infinity, but it's all of them, so it's -1 to infinity, -1 to infinity, and that would be our answer. For D, we have -1, 2, intersection with 0, infinity. So this -1, 2 is -1, 0, 1, 2. The intersection goes from 0 to 1, 2, 3, all the way to positive infinity. So the numbers that are the same in each are the 0, the 1, the 2, and that's it. So it's just 0 to 2, including 0 and 2.